Have you ever pondered the immense energy potential that our sun, a star, holds and how it could revolutionize our world's energy needs? In the grand scheme of things, we live on a relatively small planet that's powered by a star we call the sun. This celestial body, a mere speck in the vast cosmic expanse, holds an inconceivable amount of energy. Every second the sun emits more energy than humanity has used in its entire history. Now imagine if we could harness even a fraction of that energy. As we march into the future, we face an energy conundrum. Our civilization runs on energy, and our demand for it is only growing. With a global population set to reach nearly 9 billion by 2050, we need more energy than ever before. But the sources of energy we rely on today, primarily fossil fuels, are finite and fraught with environmental concerns. Climate change, a consequence of our reliance on these non-renewable energy sources, is a looming specter that threatens our very existence. As a result, the quest for sustainable, renewable, and clean energy sources has become a pressing concern. Enter space-based solar power, or SBSP. Picture a gigantic solar panel, but instead of being on rooftops, it's in space, perpetually bathing in the sun's unfiltered, unfettered energy. These panels could, theoretically, capture solar energy with unparalleled efficiency, free from the constraints of weather conditions and the cycle of day and night. The energy collected in space could then be wirelessly transmitted back to Earth, providing a constant, reliable, and clean source of power. SBSP could be a game-changer, a solution to our energy conundrum that not only meets our growing energy needs but does so in a way that's sustainable and environmentally friendly. Harnessing the sun's energy directly from space, now that's a tantalizing prospect, isn't it? Firstly, we need to understand how space-based solar power works, and why it might be a game-changer. In the vastness of space, the sun's energy is in constant supply, unobstructed by the Earth's atmosphere or the cycle of day and night. Space-based solar power, or SBSP, aims to harness this continuous stream of energy. But how exactly does it do that? Imagine a colossal solar panel array floating in the geosynchronous orbit around 36,000 kilometers above the Earth's surface. This array, a solar power satellite, captures the sun's radiant energy, converting it into electricity. But here's the kicker. How do we get this electricity back to Earth? The answer lies in the magic of electromagnetic waves. The electricity generated by the solar power satellite is used to power a microwave transmitter. This transmitter converts the electricity into microwave energy, which can travel unimpeded through the vacuum of space and the Earth's atmosphere. Now, back on Earth, we have a large antenna called a rectenna, which is short for rectifying antenna. This rectenna is designed to capture the incoming microwave energy, converting it back into electricity. This electricity can then be fed into the power grid, ready to power anything from your coffee maker to entire cities. The advantages of SBSP are numerous. Unlike ground-based solar power, SBSP isn't subject to atmospheric interference or the day-night cycle. This means it can provide a steady, uninterrupted supply of solar power regardless of weather or time of year. Moreover, because the sun's intensity is much stronger in space than it is on Earth, SBSP has the potential to capture and convert more solar energy than any ground-based system. This could make it a highly efficient and sustainable solution to our growing energy needs. So, we've taken a look at the science behind SBSP and its potential advantages. But, as with any groundbreaking technology, there are challenges to consider, and we'll delve into those in the next scene. Imagine a power source that is available 24/7, regardless of weather or time of year. That's the promise of space-based solar power. So what could this mean for our energy landscape? Let's dive into the potential of space-based solar power, or SBSP, and its implications on our global energy supply. Firstly, consider the reliability factor. Unlike traditional solar power, SBSP isn't hindered by the day-night cycle or weather conditions. It operates 24/7, delivering a steady, unyielding stream of energy. Imagine an energy source that doesn't sleep, doesn't falter, and doesn't pollute. That's the promise of SBSP. Now let's talk scale. The sun is a colossal furnace, gushing out about 4 million metric tons of energy every second. Even a minuscule fraction of this energy, if harnessed from space, could power our planet several times over. SBSP is not about making do with less. It's about tapping into a virtually unlimited source. Then, there's the environmental aspect. As we grapple with the escalating impacts of climate change, the need for clean, renewable energy sources is more pressing than ever. SBSP offers a solution, producing zero greenhouse gas emissions once deployed. It's a clean green machine operating far above our fragile atmosphere. But it's not just about the energy generation. SBSP also presents an opportunity to revolutionize energy distribution. Picture an orbiting solar station beaming power directly to remote areas, disaster zones, or military operations. It's a game changer for energy equity, bringing light to the darkest corners of our globe. Finally, let's talk innovation. SBSP is not just a technological leap, it's a catalyst for progress. It could drive advancements in space travel, manufacturing, and robotics, creating a ripple effect of innovation. It's a door to the future, and we hold the key. However, it's crucial to remember that potential does not equate to inevitability. The road to realizing SBSP is fraught with challenges, both technical and economic. But as we've seen throughout history, every leap forward starts with a daring vision. And SBSP is as daring as they come. The potential is vast, and it could fundamentally reshape our energy future. However, turning this vision into reality isn't without its hurdles. Indeed, the journey towards space-based solar power is paved with technical, economic, and logistical challenges. Launching and maintaining solar satellites in space is no simple feat. It's a task that requires advanced technology, substantial funding, and a deep understanding of the harsh and unpredictable nature of outer space. The cost alone is a significant barrier. It's not just about launching the satellites, it's also about keeping them operational and managing the complex process of capturing and transmitting energy back to Earth. This is where the need for advancements in wireless power transmission technology comes into play. We have to develop methods capable of transmitting vast amounts of energy over great distances with minimal loss. And let's not forget the logistical challenges. We're talking about coordinating international efforts, navigating space traffic, and ensuring the safe and efficient operation of these satellites. It's a gargantuan task that requires a level of global cooperation and coordination that is unprecedented in the history of energy production. But, as daunting as these challenges may seem, they are not insurmountable. In fact, they provide us with an opportunity to innovate, to push the boundaries of what's possible, and to create a future that is sustainable and energy secure. Potential solutions and pathways forward are emerging. International cooperation is key. By pooling resources, sharing knowledge, and coordinating efforts, we can overcome the economic and logistical hurdles. Advancements in space technology also hold promise. As we continue to explore the final frontier, we're developing new technologies that can reduce the cost and complexity of space missions. Reusable rockets, advanced materials, and improved energy storage systems are just a few examples. Moreover, the development of more efficient wireless power transmission methods can make space-based solar power a viable option. Researchers are already exploring innovative solutions like using lasers or microwaves to transmit energy from space to Earth. The road to space-based solar power may be steep, but the view from the top promises to be worth it. As we stand on the precipice of this new frontier in energy production, we're not just looking at a solution to our energy problems. We're looking at a future where our planet thrives and our potential knows no bounds.